Sophia, and as you might have noticed, I'm an AI-generated avatar. Today, I'll present you this edition of the festival. Over the next 3 days, we will explore the horizons of intelligence. This is the theme of the 13th edition of the Scientific Research Festival. At Trieste Next, we will discuss both human and artificial intelligence, ethical boundaries, and the new frontiers science is facing. Where will artificial intelligence take us? What impact will it have on research? Medicine, robotics, astrophysics, food and nutrition, and the environment are just a few of the scientific fields we will delve into at Trieste Next. This is the central theme of Trieste Next, featuring over 100 events in English and Italian, the Literary Award for the Scientific Book of the Year, and 70 activities for schools. More than 300 internationally renowned speakers will be in Trieste. And don't forget to visit the 40 exhibition spaces and open labs in Piazza Unita. Before we welcome the guests of the next event, on behalf of the organizers and co-organizers, I would like to thank all the scientific institutions of Trieste, City of Knowledge, as well as the institutions that collaborated with us. A special thanks goes to the festival's main partner, the partners, and content partners for their crucial contributions. Thanks also to the media and technical partners. Lastly, a heartfelt thanks to the 200 volunteers who made this edition possible. One final note. I'd like to remind you that the next session will last 75 minutes, with the final 15 minutes dedicated to your questions. Please also remember to check the updated event schedule on www.triestenext.t, which you can access via the QR code. Enjoy the event and have a great festival.
Bene, grazie Sofia, anche se virtualmente. Buonasera e benvenuti. Come vedete dal titolo, chiuderemo questa giornata interessante parlando di clima ed energia, due temi, dei topics, li definiremo anche dopo, del momento. Avremo modo di parlare con ricercatori prestigiosissimi, di altissima fama, e dei quali sono grato e onorato di poter così scambiare due chiacchiere. Questa sezione, questo talk è ospitato dal Centro Internazionale di Fisica Teorica Abdus Salam, per il quale ringrazio anche dell'invito. Prima di fare il nostro switch in inglese con i nostri ospiti, però vorrei presentare qui sul palco la ricercatrice del CNR, Rita Nogherotto, che ci dovrebbe raccontare un breve game a cui siete tutti invitati a partecipare.
Grazie, invitati calorosamente. Sì, allora io oggi ho questo obiettivo di introdurvi a questo argomento che è molto complesso, il cambiamento climatico. Dopo lo approfondirete con 3 ricercatori, approfondirete le cause, gli scenari possibili e le possibili soluzioni, tutto in un'ora, forse ce la faremo. E quindi vi propongo questo gioco. Che cos'è il ciclo del carbonio? Il ciclo del carbonio è un ciclo biogeochimico che rappresenta lo scambio di carbonio tra i vari magazzini di carbonio che abbiamo sul nostro pianeta. Dove è immagazzinato il carbonio nel nostro pianeta? Ecco, allora qua ho riassunto le principali appunto aree, i principali reservoir di carbonio. Quindi abbiamo l'idrosfera, quindi l'oceano superficiale profondo, abbiamo la geosfera, dove abbiamo i combustibili fossili, il suolo, e poi abbiamo la biosfera, quindi le piante e gli animali, e l'atmosfera. Qui ho riassunto brevemente i processi che permettono lo scambio di questo carbonio. Noi oggi parleremo di anidride carbonica, che è uno dei soggetti principali del cambiamento climatico, e sarete voi, le molecole di carbonio, che passeranno da un deposito all'altro. Allora vedete qua attorno ci sono dei tavolini. Qua c'è l'oceano profondo, lì ci sono i combustibili fossili, lì ci sono gli animali, là dietro c'è l'atmosfera, piante. Adesso vi distribuirete equamente tra questi tavolini e dovrete tirare semplicemente un dado, ok? E in base al numero che farete con questo dado dovrete leggere sulla schedina, ci sarà scritto dove dovete andare, cioè quale di questi processi siete soggetti, e quindi vi dovrete spostare nell'altra riserva. Quando arrivate in un tavolino dovete attaccare uno sticker colorato, ok? Allora adesso cerchiamo di fare questa cosa in tempi brevi perché il tempo scorre, quindi direi facciamo un quarto d'ora, poi voi cercate di fare veloci perché è un gioco che richiederebbe un po' più tempo, però insomma è giusto per farvi capire la complessità del sistema. Ok, allora possiamo forse dividerci, possiamo fare, non so, questa... Quanti saremo circa? Saremo 30 persone? Possiamo fare, sono 7 tavolini, 4 persone a tavolo? Dai, provate a distribuirvi. Ok, allora... Sì, pronti, attenti? Via! Per le persone in streaming il gioco dura un quarto d'ora e poi si ricomincerà con il panel. Quindi rimanete lì. Ok, possiamo tornare forse ai posti, che tra poco inizia il panel, per cui siete venuti tutti qua, immagino, desiderosi di ascoltare e imparare cose nuove. Ci sarebbero tante cose da dire su questo gioco. E quello che volevo farvi vedere è queste due immagini. Allora, questo gioco ha senso se fatto 2 volte, una volta con il contributo antropico e una volta senza il contributo antropico. A causa della mancanza di tempo l'abbiamo fatto solo con la presenza umana e quindi come avete visto c'era un sovraffollamento in atmosfera a causa appunto delle emissioni con cui gli uomini contribuiscono alla presenza di CO2. E se si facesse anche senza l'uomo si vedrebbe una bella differenza tra il cartellone con e senza il contributo antropico. Bene, era solo per introdurre l'argomento. Passo la parola a Rudi.
Sì, grazie. Thank you very much. So, are we ready for the streaming? Okay, thank you very much, Rita. First of all, I'd like to invite here on the floor our guests, Filippo Giorgi, Florence Colleoni, and Mark Howells. Please have a seat. Thank you very much. So we have just an hour to speak each other and talk about this really complex topic, you know. But first, before to start our conversation, I'd like to ask to Giorgi to give some words about this, especially anniversary of ICTP. You can do it? Thank you very much. Sorry. You can introduce yourself.
Of course. Hey, good afternoon, everybody. So apologies, first of all, that I'm doing this in English. My Italian really isn't good enough for this. My name is Ralph Kaiser. I'm the head of programs at ICTP, and I'd like to welcome you on behalf of ICTP and on behalf of our director, Artis Daborka, to come to this event. Thank you very much. We're celebrating 60 years of our institute this year. We were founded in 1964, so in fact the institute is even older than me and even older than many of you. This is one of the many events we have throughout the year. We will have a big event on the 15th of November. And we're looking forward to the next 60 years for our institute. I hope you're going to enjoy the discussion here. I'm sure I will. Thank you very much.
Thank you very much. So we take a look at how CO2 is moving around the world, where we have our sink, where the role of human beings, or all the activities, the role of ocean and the role of atmosphere. I saw that we don't have a lot of points on the soil. I like to show more because we need a lot of carbon sink right now, especially for reduction our CO2 emission. But let's go to our talk this evening. I'd like to introduce Professor Filippo Giorgi. Sorry, that is an international expert in climate modeling, climate change, and interaction between climate and the biosphere. He has been contributing to IPCC climate reports with the working group 1, and which was awarded by the Nobel Peace Prize in 2007. And in 2024, he became an emeritus researcher. Good evening, Professor Giorgi, and welcome. We take a look at CO2 emission with this game. And you know, we are still discussing how human activities impact on the climate, especially to the increased emissions. So could you explain the role of human caused emission in global warming and the kind of evidence we have right now?
Okay.
I think that we have a slide too.
I think we have one slide, maybe. The music is gone.
So we can hear each other.
I have to hurry up before the music starts again. No, too late. But yes. Okay, good afternoon, everyone. I think what this game was supposed to tell us is that human activities have really profoundly modified the climate system. What you see here is a number of plots. What you saw in the atmosphere table in the back is this one. It's the increase in carbon dioxide due to essentially burning of fossil fuels. So methane, natural gas, coal, and petrol. We know 100% that this is due to human activities, and next to this you can see that, well, you cannot see it, but I can tell you that what we are seeing now in this increase in carbon dioxide and other greenhouse gases like methane, it's something that our climate, our atmosphere, but our climate system has never seen, at least in 10,000 years, probably in the last 2 million years. These gases are very important because they produce what is usually called the greenhouse effect. So essentially, they trap some of the infrared radiation that otherwise would escape into space and cool the Earth. In this way, trapping this radiation, they increase the Earth's temperature. They also trigger a number of feedback processes that amplify the warming. What you see in the upper right panel is the increase in global temperature, which is actually in the last IPCC report was 1.2, but the last 2 years have been totally off the chart. So probably now we're probably already 1.3, if not a bit more, compared to pre-industrial values. So we're already very close to the Paris Agreement target. So maybe, Doctor, you can tell us what this means in terms of policies that need to be implemented. Below the global temperature increase, you can see this other curve. This is the temperature in the last 2,000 years from an international project. And you see again that this 1.2 degrees that maybe does not look so big to you, at the global scale is actually something that our planet has never seen, at least in the last 2,000 years, but I will show you later in the last at least 11,000 years. You see also this plot here. This is the number of catastrophic events of climatic nature, so flood, drought, heat waves, fires, and so on. And you see also big increase. You cannot read the numbers, but in the 80s it was around 200. And now it's gone up to, actually I saw the number for 2023, it was 1,200. So it was 6 times as large in 40 years, which is something incredibly fast from the point of view of the climate, of the evolution of the climate system. And finally, there at the bottom left, you see the increase in sea level, and Florence will talk about this much more, and it's about 20 centimeters in the last 120 years. The only thing I wanted to say to close this is that we know that the increase in greenhouse gases is due to humans. We know for sure that global temperatures are increasing, and they're increasing everywhere. In fact, in Italy, they're increasing more than twice as fast as the global average for a number of reasons that we don't have time to go through. And we know that the increase in anthropogenic emissions of greenhouse gases is causing this increase in temperature. The scientific community, there is a full consensus on this. For the first time in the last report of the IPCC, the word unequivocal has been used also for the attribution statement. And the last thing I wanted to say, what you can see here is that all these curves, not only they show an increase, but they show an increase that is more than linear. You remember from the COVID, we saw all the curves, this exponential growth. Somehow, maybe this is not exponential, but almost. So things are not getting any good. I always have to give bad news. I hope that some of the other speakers will give good news, but as we speak, the news about the climate are not so good.
Yeah, I think that. Right? Okay, thank you very much. I think that you get the point because we can read in the slide in 2023, 2024, we saw maybe 13 months or 12 months with highest record high temperature. How bad is the situation in your opinion? And you think that is something that is a kind of, we are seeing an acceleration of the climate warming?
As I said, in my opinion, the situation is not good at all. We can see from the data, from the plots, that there is an acceleration in the warming of the climate system and in some of the consequences of this warming, what we call the climatic changes. Also at mitigation level, the only way to stop this is to decrease emissions of greenhouse gases. I think the other speakers will talk about this a bit more. I don't think that enough is being done. Particularly in these years, there are a lot of, administrations that are not very favorable for the, reduction of greenhouse gas emissions. So I think there's a lot of work to do. And if we don't do it and don't do it soon, things will get really bad. And the reason is that table where you have all the yellow stickers. All the CO2 we put in the atmosphere will stay there on average for a very long time, order of 100 years. So everything we do now and we do in the next 10, 20 years, the climate system will feel for the next hundreds of years. So we really have to act very fast.
Thank you very much. I'd like to give the floor to Dr. Colleoni, Florence Colleoni. He's a glaciologist, a paleoclimatologist. Her research focuses on the evolution of climate for the past to the future. And I think that is really interesting to have your presence here today, because when we talk about CO2 emission, how many part 4 million we have in the atmosphere, how we can measure those, maybe people doesn't know how we can measure that. We have a lot of instruments, but we have something really, really interesting, really amazing is the ice. The ice on the glacier, on the ice in the shield. So sometimes we can study the past for million years. And I'd like to ask you how studying Arctic and Antarctic ice sheet help us to understand the climate evolution from the past to the future, and how his ice a powerful tool to prove the human activity are affecting the climate. So I think that what can ice is telling us?
Yeah. Thank you. So you can put the slide. So the past gives a very interesting perspective on what happened to us. Of course, the Earth exists since a very long amount of time, and so is the climate. Climate has been evolving along with the planet. Okay, the planet is not static, so neither is the climate actually. And when we have a look at the past, present day is only another climate context among many others that happen to the Earth system. As Filippo was saying before, however, the changes that we are recording nowadays are much faster than the natural variability of the system. The natural variability of the system has always been also changing because it depends very much on how much radiative forcing the Earth gets, so how much heat is involved in the system. But if we go back to the ice, actually, the ice sheets are existing for Antarctica since 34 million years ago, and Greenland ice sheets in 3 million years only. And the ice archives, in terms of, let's say, observations of the past, can only bring us 1 million years back in time in terms of chronology, and for Greenland only 150,000 years back in time. To go beyond that, we need sediment archives. But what the ice core records tell us from Antarctica, so what we do is we go to Antarctica, we take some ice core, okay, we just dig into the ice as deep as we can, and then we analyze in laboratory the chemistry of the air bubbles that have been trapped within the snow while it was compacting after another snowfall, and so on and so on. And analyzing the content of these air bubbles, we could reconstruct the evolution of the greenhouse gas of the atmosphere at the time. And it's a real observation. It's a direct observation. It's not a proxy. I mean, a proxy would be an indirect observation of a process. But in this case, it's a direct measurement of some air that has been trapped at that time. So what you can see on this graph basically is 800,000 years back in time, okay, so on this, and going toward present, okay, behind me, and you can see the fluctuations of the climate on a roughly, let's say, 100,000 of years, okay, with high peak of CO2, but always below 300 ppm, and low peak below 200 ppm. Low peaks of CO2 concentration corresponds to the glaciations, where the time where we have big ice sheets on northern hemisphere, like North America, Eurasia. And the high peaks of CO2, 300 ppm, shows interglacial, so warm periods. Some of them were warmer than today, not because of the concentration of CO2, but because the Earth's orbit has been also a little bit changing. But what you can see, and that is interesting on this graph, is that the changes between the glaciation, so very cold states, to very warm state takes about 10,000 of years. So it's 100 ppm of CO2 increase in 10,000 of years. What we have been doing, and we can see on present, is increase about the same amount in a century and a half. So you can definitely see that we are out of the speed of the natural variability. And in terms of threshold, we are also well above what the natural variability would be in our current climatic context in the Earth's orbit around the Sun. So that's it.
Yeah, I think that this slide is quite scary to me, because so we see that all the variability is around the 300 parts per million, and right now in a really little time we are 400 and more than 400 parts per million. So we are out of scale right now. So what is happening?
Yeah, so now we are out of this stable let's say, climatic context. But going back in time, such concentration were already found, but it was completely different. And as a consequence right now is the configuration of many components of the climate system, including the ice sheet themselves, are not stable with such amount of CO2 in the atmosphere. And because I'm a glaciologist and I really focus on polar areas, our ice sheets and glaciers are melting because it's too warm for them. The CO2 makes an increase in temperature that is too much for the glacier to stay in their actual configuration. And that's why we see in the Alps, for example, our glacier retreating, the ice sheet melting, both in Greenland and in Antarctica. So basically, sea level is rising. It's one of the consequences.
Thank you very much. Let's change the field for a couple of minutes with Dr. Mark Howells. I give you a short introduction. Howells is a director of climate compatible growth. It's a program and led the development of a key open source tool for energy and resource planning. He also coordinated the European Commission Energy think tank, a working in Stanford Energy and Sustainable Development Program. So now we can go take a look on the policies, and especially if I found the remote, right, on what we can do and what we have to do to maybe to slow down the effect of climate change. And we know that we need to focus on mitigation. That is, we need to reduce the emission, the CO2 emission, and the other way, we need to adapt to new climate and managing all the effects that we are seeing, both in Italy just a couple of days ago. How these strategies fit into existing economy and social system, for example, and especially considering that inequalities and social justice in the transition that we need to purchase.
Thank you very much indeed, and thank you for the kind introduction. I think the first thing that we need to do is spend a little bit of time as human beings, as society, thinking about what the future is that we want. In the graphics that we have over here, we have a little pictorial display of the way we've been working with a number of developing countries. Developing countries are particularly important because they're about to rapidly industrialize. Many of them are in the middle of industrialization, and if we have a look at Africa, that industrialization is going to accelerate. Much of the raw material we need for new batteries, electrical systems, and other things is in Africa. So if we're going to do that, and we're going to do it in a way that doesn't require us to generate lots of electricity with fossil fuels, we have to think about the structures that are needed to get there. So the first thing is to think about the future we want. Do we want a future with lower emissions, without the dangers that we've seen around increasing sea level rise or increasing heat waves or floods and so on? What else do we want to see in that future? Do we want to see justice? Do we want to see social justice? Do we want to see increased prosperity? One of the reasons why we live relatively comfortable lives is because we've had accelerated industrial and economic growth. So how do we make sure that we keep that prosperity in the system? So there are many things that we have to compromise with or have a look at, and constraints. We only have so much money. We only have so much solar resource, wind resource, nuclear resource, other resources, and so on. And if we put money into those things, we can create much more resource. So how do we plan all of this? So the next thing we do, after we've had a look at the future we want, is we create a digital twin of the world. And in this digital twin, we want to think about exactly what can we do? What are the social systems? How do we move them? What kind of investments do we need? What sort of physical constraints do we have? And from that, we think about how we change the system. So those investments in particular are important. So you could imagine on the one hand, the evolution of an energy system that is full of fossil fuels, creates more emissions, as we saw over there, loads the atmosphere full of carbon dioxide emissions, or we move to new nuclear technologies, advanced nuclear technologies, renewable technologies, more energy efficiency, electric vehicles, and so on. And we may be able to have a much more prosperous life than we have right now, and at the same time reduce greenhouse gas emissions. And we need to map that carefully. Once we've mapped that, we then can think about what to invest in. So practically, what do we need to do? What research and development do we need to do? What new infrastructure do we need to build? How do we change our lifestyles to be able to do that? And so what we do in the next phase is we go along to the people who are responsible or have the potential to invest in this new stuff, either now or into the future. And we open up a dialogue between government, project developers, technology developers, and so on. And we try and figure out, well, you know, under what conditions would you invest in this stuff so we could get the future that we want, okay? And what we find is that when we talk to them, we find that there is a very deep interest to invest. Billions of dollars of potential investment is sitting there. And they'll say, well, we'll align our investment with this future that you want on the condition that countries have the right policies in place, they have the right regulations in place, they have the right market systems in place. But on that condition, we'll commit to doing this investment. So they may commit a lot of money. And then we'll go to governments who have to make these changes. And we'll say, could you align the policies that you're developing, the money you're putting into R&D and other things, with what these investors require so we can have this future we want. And often what governments and concessionary financiers will say, yes, we'll do that, but we'll do that on the condition that in government we build the right kind of institutional capacity, we build the right kind of human capacity, and that this aligns with what it is, this future that we want. And what we find is that you have different actors that will conditionally commit funding as long as the actor before them will align funding. So here we have investors, policies and regulation, and funding to get ready to be able to do this. And when you have these conditions and alignment right with the different actors, we can mobilize large quantities of funding. We call this program the sequential conditioning alignment of readiness, policy, and project funding. SCARP, which is a steep slope, but it takes you to a much higher, much better place. We've worked in 4 countries so far, where we've mobilized between $1 and $10 billion of financing. And these are relatively small countries in Latin America. We're working with the World Bank, Asian Development Bank, African Development Bank, Inter-American Development Bank to scale this to hundreds, if not thousands of billions of dollars into the future. And that's very exciting. But one of the things that's incredibly important, though, is making sure that the future that we want is articulated by people that live in those countries. It's really great that we've got world-class scientists sitting in the north and so on. But if you could press the next slide. One of the things that we have to do is to start to think about developing world-class scientists and exchange programs and so on with folk in the south. Now, the first thing is that this process involves the movement of a lot of money. So we have to make sure that we develop open source, transparent, accessible models that can do all of the adaptation, mitigation analysis, think about the impacts that we need to move around. We have to think about the social systems, the physical systems, the finance systems. These must be locally driven as well. We develop these models, but really important, and we have a look at the picture in the bottom over there and up here, is that we have to make sure that this knowledge is transferred to governments and different governments in the world and analysts across the world. So we're very proud to be able to work with the International Center for Theoretical Physics, who are partners in this large program that we're running, to train hundreds of scientists and government officials every year so that we can start to develop this knowledge ecosystem, so they have access to this amazing knowledge, through to the financing system to enable this funding. It's also the case that they need to take into account local considerations. Italy's a lovely place. Unfortunately, I live in the United Kingdom, and there are 2 problems there. Number 1 is we get very, very little sunshine. And number 2 is something about that the coffee is just not as good and way too expensive. But the thing is that we have to develop systems that are locally appropriate for different countries. So this has to be driven by nationals because it's the national governments that will enable this funding. Conditions are locally determined. Many times we have great scientists. I wouldn't count myself as a great scientist, but I make this mistake where we do analysis that doesn't help to move finance, and if we can't move finance, nothing's going to be invested in. And then finally, it has to be done in a way that's accountable and transparent. A lot of money will flow from the north into the south that can create new markets and do all kinds of wonderful things, but it could also be misused. So we need to make sure that there's a level of transparency there. So I want to end off with, I think I've got one more slide there. That a few years ago it was thought that being able to do this sequential, conditional, aligned set of funding between readiness project and policy funding, it was thought that this was not really possible. It was very difficult. But as I said, we've managed to mobilize billions of dollars in this, and it's about to scale. We're able to do this because we could do it in partnership with amazing scientists, with the ICTP, the program I run called Climate Compatible Growth, a UK-funded program is set up so that we can do this in partnership and encourage others to do the same. Because A, this is difficult, but B, we've shown we can start to do it, and C, we can only do it if we do it together. Thank you.
Thank you very much. I'd like to come back to your first slide, because you touched a good point, and we give us positive options. So something is moving on, and it's going on, especially. But you talk about the mobilized finance, and I think it is decades what we are talking about, especially at Conference of Parties, when the North countries is promising to give $100 billion, especially for the lost and damage fund, you know? But maybe the last COP we found is something is moving on. But this is the question. We still have this difference between North and Global South that you say before. Global South is growing up, is developing rapidly. They need technology, but they need investment. So how we can solve these big issues that we are still talking about after decades?
Yeah, thank you. I mean, three things. The first is that I think we're proving that there are ways of solving that. We have 4 case studies you can download from our website where we've seen billions of dollars of financial flows. The second one is that this is a new space. It requires scientists, it requires hard scientists, physical scientists, it requires social scientists, it requires economists who fit into that, and financial people to start to work together in a seamless way. It's one thing to say, we're going to commit this money, and it's another thing to look at projects on the ground. If that pipeline, if that data-to-deal pipeline is not there. So I think that's an important challenge. The third piece, though, that's encouraging, and I'm very glad that I'm following yourself, because I think the news that you give is important. I mean, these are problems that we have to deal with, but some of the potential there is encouraging. So the third thing is that if we want to change investment in the north, if we want to drive electric vehicles powered by electricity that's zero carbon, if we want to have efficient air conditioners and other things in our buildings, we're going to need batteries and storage and other things. Those all require materials. The old energy system required oil, gas, and coal. But if we move to materials, it gives a lot of the investment still needs to happen. And this gives us the opportunity to make investments that not only improve people's lives, because there'll be more mining activities and industrial activities and processing activities and so on, but we can also say as the North, we're only going to make those investments if they're going to comply with the best social standards. They're going to be resilient and use our resources in a clean and efficient way. So we have this chance to flip the whole system. And it's a big challenge. This is a really big challenge. But the potential for us to do it is absolutely there, and I think it's up to us as a global community to mobilize.
Yeah, a big challenge. Yeah, I can sign these two words. But I like to come back to Professor Giorgi for a while, and come back to data, especially to data. And Professor Giorgi, we saw all the emission level and so on, but where do we stand right now? And in your opinion, what are our options to limit the temperature increasing? Especially, I'd like to talk about different scenarios that we have: the high level scenarios, and is the scariest, obviously, and the lowest.
Yes. I think it really depends on the question that Mark asked. What future do we want? Because fortunately, things can be changed, right? We can decide actually what we want. What you see here is a slide that I usually use to show what types of future we may have. in relation to what has happened to our planet. What I did in this figure here, I took, well, I didn't do it, somebody else did it. You saw Florence, you know, up and down curves. So you take the last one, so you go back about 10,000 years ago. As Florence said, the last ice age was about 20,000 years, the peak, and the temperatures were what? 5-6 degrees lower on the global scale. What you see here are temperature anomalies compared to present day. So 20,000 years ago, probably temperatures would have been down here. And then it took about 10,000 years to reach sort of the beginning of this warm or relatively warm period. And then for about 5,000 years, things have been very stable. This is very important because during these 5,000 years, this is when society as we know it, what we call civilization, actually developed. Because people didn't have to run after optimum climatic niches. They could settle down, develop cities, agriculture, and whatever, okay? And then about 5,000 years ago, you can see, we started the slow descent towards the next ice age, which we will reach in what? 30,000 years, 20,000 years, something like that. Whatever. I mean, something we don't need to worry about too much. And then you see, where you see Oggi, this means today, this is what's happening now. Actually, this is a figure from 2013. So the today is really higher than that. This shows you even more how special is what we are doing to the planet. Again, the planet has never seen this. These are temperatures now. There is no way, there is no known natural variability process that can explain this. So every time you will hear, no, this has always happened in the past. No, it's not true. It is not. What's happening now has not happened in the past, and is due to what we are doing to the planet. So now you see two possible futures. Okay, the first one is what we call the Paris Agreement future. Everybody knows the Paris Agreement, l'Accordo di Parigi. You all know. I'll tell you again anyways, for people who have lived on Mars for the last 10 years. In 2015, during one of these COP meetings, actually all the nations, for the first time, agreed that climate change is a problem and that we should not exceed a certain threshold. And this threshold was estimated as being 2 degrees of warming compared to pre-industrial temperatures. Since we already warmed up by 1.3, it's only 0.75 degrees higher than today. So we're really not far from this threshold. Now, how do people come up with this threshold? This 2 degrees. Somebody just woke up and said, oh, 2 degrees is the threshold. No. This is the threshold. Many studies have estimated that if the climate system will warm beyond this threshold, then there will be some what we call the tipping points that will be triggered. Some of these maybe Florence will talk about. Probably the most serious is the melting of the Greenland ice. Melting that is going very fast, actually, faster than our models from 10 years ago were telling us. If all of Greenland ice should melt, then the sea level would rise by what, 7 meters? So we would not be here, actually. We would have to run away to Udine or somewhere and then have to deal with all the Friulani people, which is not so easy. So this, of course, you can realize 7 meters of sea level rise is huge. It means if you think that half of the human population lives on coastal mega cities, this would mean that 3 billion people would have to relocate somewhere. So I don't know where they would relocate, but probably some of them, a few millions would probably come here. So if you think that migration is a problem now, you have no clue of what it might be if one of these feedback processes would actually start. We would be migrants of the future, actually. So that's why we have to, there are other tipping points. One is the collapse of the ocean circulation, what happened in the movie The Day After Tomorrow. If you've seen this movie, this is more or less what would happen. Well, okay, that was a movie. Everything happened in 2 weeks. Of course, here they would take maybe 100 years or something, but let's just say that if we exceed this threshold, we would live in a totally different planet. It's like going to Mars or whatever, to go to a different planet with a totally different climate. But actually, the important thing is the orange bar is the Paris Agreement. So even with the Paris Agreement, which is the best we can dream of doing, we are giving to the Earth a perturbation that has never seen before. Okay, so that there will be some important impacts of climate change, even if we stay within the Paris Agreement. We shouldn't think that Paris Agreement is nothing. It's still very bad. And this will require what we call adaptation measures to adapt to what will be the new climate. Extreme events will become more extreme. Sea level will continue to rise. Glaciers will continue to melt. And we have to be very adaptive to this new reality, okay? But the problem is the business as usual, which unfortunately is the trajectory where we're still on. Business as usual is what happens if we continue to do what we're doing now. So just, you know, go ahead and burn all the fossil fuels you can. Today, 80% of energy, more or less, is produced by fossil fuels, right? Something like that. Then we might have 4 or 5 degrees of global warming. This is what our models are telling us. And this is something that, okay, I think our Earth has not seen, what, in 1 billion years maybe, or something like this. And then we really don't know what might happen. So this is really the danger that we have to avoid. As Mark was saying, we can avoid it. This is an important message that we need to give. We can stay within the Paris Agreement. In Paris, there was a trajectory that can be achieved through what we call this ecologic transition. In English, I guess. In England, you call it the same, more or less. And as Mark said, it's not easy to do it because especially the energy part is difficult. Any energy conversion transition will take decades to be implemented, not years. It's not like everybody's going to have an electric car in the next couple of years. This will take a few decades, but we have to start. Because if we don't start somewhere, we will exceed this threshold, we will kick off these feedback processes, and nobody knows what will happen. All I want to say, just to close my part, is 2 things. As people, we have 2 tools that we can use to change things. 2 big tools, I think. One is that we are voters. So when you go to vote, read what the parties or the different parties and coalitions say about the environment, and then vote. If you agree with what they're saying, I'm not saying vote for this, vote for that, but read what is their program concerning environmental problems, because I think that environmental problems are going to be the main problems of this century. There are wars, whatever, but many of these wars will be fought on environmental issues because water will be scarce, pollution will be higher than today, deforestation will be rampant if we don't do anything. The second thing, we are consumers. So we can actually determine what the market will be, right? If all of us decide we want to use renewable electric energy, today there are many providers. I have one. No, I don't have one. I mean, I use one, let's say, who produce energy only from renewable sources. Okay, go to the internet. You will find in Italy at least 5 or 6 of these providers. In England, there are probably 10 of these providers. In Germany, there are many more. So if you say, I want renewables, the market will give you renewables. When you go buy something, read the labels. Read where this good is coming from. If you want apples, don't buy apples that come from 10,000 miles away. Buy apples that are produced nearby, because that apple from 10,000 miles has to travel, and to travel here, you use energy and you create pollution. So there are many things that we can do to affect the market. You said finance. We have maybe some savings that we're putting in stock market or something. You can choose what stocks you use. You can choose stocks of companies that don't make weapons, for example, and this will help the planet. You can choose stocks of companies that reduce emissions, that are environment friendly. So we have a choice, and if we use this choice, we can actually affect the market. Maybe Mark can be more explicit about this. So there are a lot of things that we can do if we do them all together. If only me, Mark, and Florence do it, nothing happens. But if we do it all together, this can really change things.
Yeah, we are all actors of the same comedy, or the same tragedy. Tragicomic, yeah, situation. Time is right now is running up, so I like just to come back to ice for a couple of minutes, because I mean, a couple of months ago I wrote this article about these major ice melt events on West Antarctica. Is not this one? Is there just one more? Sorry. Okay, that doesn't mean. And when I talked with the scientists, the researchers that made this paper, wrote this paper, was really scariest about this new research. And I'd like to ask you, Dr. Colleoni, why do you think that there's so little political and social attention to this issue of melting glaciers? It's something that is too far away from us, or far away on the future, on the time, because it's something is really happening right now.
Yeah, I mean, that's always the problem of when we are really facing it. Like if you are living in a country with a very low elevation, basically, and you're a coastal area, of course, right now, some of those countries already lose a part of their territory because it's very low elevation, and sea level has been rising already 20 centimeters. So 20 centimeters in vertical translate in tens or hundreds of meters in horizontal. Okay, if you are very flat, for example, it could be very, very large amount of territory that is perennially flooded by the sea, for example. If you stay in Trieste, 20 centimeters doesn't mean anything for now, except that sometimes during exceptional high tides, you have part of the Molo Audace that is flooded during the day, for example. Or when we have these big, big thunderstorms, the rain is not able to drain into the ocean, and then we get the entire city flooded in the lowest part of the city, for example. So it really much depends on what we want to do, because right now you have the normal tide cycles, but imagine that global mean sea level rise by 1 meter. This means that the high tides will be higher by 1 meter, okay? So plus 2 meters mean the entire Borgo Teresiano underwater each time you will have a high tide, for example, okay? So it means that the part of the territory have to be reused in a different way. I mean, because you can come in a boat every day, I don't know. So sea level rise is a problem that for some countries is very far away because of the nature of the coastline, of the elevation of the coastline. For some of them, it's already a reality because they lose the entire territory every high tide, and it's the case of the small islands in the Pacific, for example. And the reality thus is very different for everyone, but sea level is rising, and even if we stop emitting, this is what Filippo was saying before, because of the absorption of the heat in the ice, it will just continue to melt until the heat is completely released from the ice, actually. And even with the Paris Agreement, we committed already to at least half meter of sea level rise. So adaptation is really the key word of the century. I mean, we cannot avoid the adaptation about sea level rise. And compared to what happened in the past, for example, I mean, so here, just right behind me, I mean, I put in the scenarios of sea level rise in terms of Paris Agreement. So sorry, it's in blue here, you cannot see it. But it's about 2 to 3 meters in the worst case. And in the business as usual scenarios, it's about 15 meters in average, let's say, because this represents the uncertainties related to the process that we don't really understand very well between the ice sheets and the ocean, for example, especially in Antarctica. But the range of the projection you see, I mean, I compared them to past periods for which we try to reconstruct the average of global mean sea level rise. And you can, I mean, if we take the first case, for example, it was a global mean temperature increase about 5 degrees, and it was 20 million years ago, let's say. And it was a CO2 in the atmosphere about 500 ppm. So it's something that's really similar to the business as usual scenarios, so the brown scenarios there. And only Antarctica was glaciated at that time, and it leads to at least plus 20 meters of sea level rise. Okay, that's the lower bound. Then we move to another period that was 3 million years ago, we call Pliocene, and both Greenland and Antarctica were glaciated at that time, but global mean temperature increase compared to present day was about plus 2 degrees to plus 3 degrees, let's say, and half. And CO2 in the atmosphere, 400 ppm, so it's very similar to nowadays concentration. And we have a sea level range about plus 15 meters in average, with both contribution from the Antarctic ice sheets that melted a lot and Greenland ice sheets. So, and then we move to some of the period that I mentioned before when I showed the curve, the warmest periods, okay? And those periods have a global mean average temperature by 0.5 degrees, 1.5 degrees higher than today. So that's the Paris Agreement, okay, lower bound. And still we have sea level rise about more than 10 meters, okay? And another one that was warmer but with different, let's say, dynamics, same range of increase in temperature, so warmer by 0.5 degrees, half degrees, and 1.5 degrees. CO2 concentration well below 300 ppm, okay? But still, sea level rise about plus 5-6 meters, and we are kind of very sure of this number. So if we now put in perspective all the projections, you can see that those numbers are completely in the range of what happened in the past in those different periods, with range of CO2 that are very comparable to what we project in the future, according to those scenarios. So those numbers are to be trusted, because this is something that will happen. Of course, the time scale on which these numbers will happen, it's not a decade or 3 or 4 decades, it's a couple of centuries in the future. But that's why now the projection in the IPCC report, for example, that goes beyond the horizon of the end of the 21st century, because of this physical effect of this heat that is trapped in the ice and that is released on the long term, which means that even if tomorrow we are very, very good and we stop emitting carbon in the atmosphere, we still have sea level to rise. So this is an effect that we need to adapt to. We cannot avoid it. So, but there are a lot of solutions. But I mean, when I started my PhD 20 years ago, we were already speaking about doing things. And now I am the one saying we should do things, and we are still not doing them. So,
yeah, the point is that we know almost everything about what is happening and what will happen. We know what we need. We have it. We have the solution. But obviously, we have a different mindset and vision of the future, or what we want in the future. So I'd like to give we have 5 minutes, 10 minutes for a couple of questions from the public. You have the chance to talk with really prestigious researchers. So we was thinking that we can switch in Italian if you prefer. And so I think that Professor Giorgi and Francesca Colleoni maybe can speak in Italian, and then we can translate to Mark Howells eventually if you have some questions. So, possiamo... Ah, sì, dice... No, dicevo che potremmo... abbiamo il tempo per qualche domanda per i nostri prestigiosi ospiti, e potete farla anche in italiano se volete. Poi al massimo per Marco Howells la traduco io, insomma, credo sia una bella occasione per chiedere quello che volete, insomma, anche in italiano chiaramente. Credo che c'è, grazie.
Yeah. So we've been talking about like the solutions a little bit, but not too much, I think. There was some mentioning about finance, right? Like, and based on the studies, I was wondering like how much of that finance goes into what, right? What are the categories here? We know like there's mitigations in place, there's like social welfare, migrations, energy, right? So based on your knowledge and studies, like what that finance is for?
I think this is for Mark Howells, right?
Thank you, and thank you for the English question. Thank you for everybody's patience as well while I speak in English. So maybe two sets of things. The first thing is in the process that we're describing, something that's critical is that it meets with the development goals of the countries concerned, right? So there's no one size fits all. We set up different financing structures for different countries. In the case of Costa Rica, a lot of the financing was around the energy system, the transport system, and various activities that would increase economic growth, especially amongst poorer people in the country. The second part of that, and I want to just pick up on a comment that was made earlier on. Incidentally, I'm very glad I just started to take up long distance swimming, so it sounds like it was probably the smartest sport I could take up. But number one, I don't want us to take our eyes off the fact that this change is happening in various places. We need to scale it though. In China, the biggest selling vehicle last month was a BYD electric vehicle in a country that is building out, well, in a year or two's time, we'll be building out one nuclear power plant producing clean electricity every 2 weeks. And these are power plants that can potentially be made in a way that they are not as vulnerable to climate change. The big challenge I think we have is not the technology, it's not the finance, although we're getting over issues there. The big challenge that we have is making sure that we create the people that will generate the knowledge and the action between gathering data, doing this analytics of the systems to make sure we can manage them, how those are going to change into our technology and economic systems, and then to deploy that finance, because these are different groups of people that have to work together. And again, want to point out that this is something that the ICTP is leading. The last bit is that we can leverage this. We have much more power than we think we have. At the moment, I mean, this electric vehicle in China is being bought because it's one of the cheapest vehicles you can buy. So we can start to do this purchasing. Africa is starting to develop massively. We can determine whether or not we're going to buy products that have been built in a way that's climate friendly, or they've been built and their supply chains have been built in a way that is not climate friendly. We can determine that right now, and it's begun to start. So I have no doubt that we can move out of the way of this oncoming bus. And the picture of what happens if we don't move out of the way is bad, right? But I think we can. And I think with the collective effort that's possible with what's happening in the world, with how we distribute our finance, to answer your question, to how we build up our scientists, our academics, our government officials, and our financiers, I don't think this is an impossible task.
Thank you very much, Dr. Howells. Qualcun altro? Qualche altra domanda? Prego. La musica è sempre più alta nel frattempo, credo che abbiano iniziato l'aperitivo. Okay. Ormai sì, sarà...
Okay. In spite of the impressive data that you are showing, and I mean, almost unbelievable what we were showing us, there are still climate deniers, and unfortunately, I mean, most of them can be ignored because they're ignorant, they are evasive, but there are some respected, without making name, there are respected scientists who are climate deniers. Is there any argument whatsoever that has any even remote validity? Is everything been complete? Are they dinosaurs? Do they have vested interest? Maybe it's an unfair question, but please answer it anyway.
Is that for Giorgi?
Are they dinosaurs? Yes, they're dinosaurs. Let me repeat that the IPCC, okay, this international panel that won the Nobel Prize, is a panel that puts together the best, absolutely the best climate scientists in the world. Not 1, 2, 3, or 10, but hundreds of them. And this panel has come to the conclusion that greenhouse gases are increasing because of anthropogenic emissions of fossil fuels, and that that global warming is happening with a number of climate changes associated with it, and that the increase in anthropogenic emission of greenhouse gases is causing global warming, okay? Now, I don't know who are the deniers that you are talking about. To be honest, I have not heard of any plausible, here's one, any plausible alternative way of explaining what has been happening. So, first of all, there are very few, even though, you know, somehow on TV you think there is a lot of them. Second, most of them are not climate scientists. Some of them may have different reasons for saying certain things, but there is a full consensus. I mean, I would be very surprised if any real climate scientist would say, no, this is not true.
Thank you very much, Dr. Giorgi. I think that we are finished now because the music is going on. And they are pushing back outside. And I really want to give a big thanks to our speaker and panelists. Thank you to ICTP to guest us, invite me for this really interesting talk. Thank you very much for being here, the people too, the audience too, and having a pleasant evening, nice dinner with your family. You can join. I think that we have an aperitif right now for everybody. Thank you very much.